Hello everyone, welcome back to International Trade. I'm very excited today because we're going to start a new topic, the topic of the gravity equation. We know from physics that gravity is that thing that makes you fall down, right? So it's the force, although I know there's, people don't want to say force, but so it's the force that attracts to objects with mass, and that force is proportional to the two objects, this typically countries' mass, and inversely proportional to the square of their distance. Obviously, this was first observed by Newton, and then with Einstein, we figure out why that actually happened. So just like gravity in physics, we also have a gravity equation in international trade, where we're not going to look at the force between two planets, right? We're going to look at the bilateral trade between two countries. And the gravity equation in trade states that these bilateral trade flows, the exports from Denmark to Germany and from Germany to Denmark, those are proportional to the product of the country's GDP. So that is the size, the economic size of the two countries. Two countries trade more when they're bigger, and it is inversely proportional to their distance. So the farther away two countries are, the lower the bilateral trade flows. So let's look actually how this looks like, how gravity works for Denmark. This is a figure that you will actually have to generate in the problem set number 6. Here what we're plotting is the on the vertical axis we have the log of export value from Denmark to all the destinations listed here. You see the U is Germany, GBR is the UK, SWE is Sweden, you also see there Norway. And the value of trade flows of exports from Denmark to these countries is plotted against the log of the destination GDP. So you see here the US is the biggest country in the world, and you have China there. And this I believe is for 6 years ago. You have, Japan, Germany, the UK, France, and so on. I mean, what you see here is a beautiful correlation between the two variables, right? It doesn't get better than this with this type of macro data set, doesn't it? So here we're actually seeing that Denmark exports more to countries that are bigger. What about the distance? Well, what we're going to do now is plot the export value divided by the destination GDP. In other words, we're going to control in a way, okay, in a very rough way, for the size of the destination by taking the total export value of Denmark to say Sweden divided by the Swedish GDP. And then what we do is we collect that and plot it against the distance. Okay, this is a weighted distance measure. Okay. And you can see here, the closest countries to Denmark are Sweden, Norway, Germany, the Netherlands, Poland, and so on. And New Zealand and Australia, AUS and NZL, are among the most distant countries. I mean, this makes sense. But what we're seeing here is that perhaps it's a little less beautiful than the previous figure, in that there is some sort of heteroscedasticity here. But we observe this negative relationship, right, whereby Denmark exports more to countries that are close. So this is gravity at work. Denmark exports more to bigger economies and exports more to closer economies. Obviously, stating the gravity equation like that is a bit simplistic. That is not exactly the gravity equation that we're going to see in this lecture, because obviously there are several other impediments to trade flows that reduce the bilateral trade flows between Denmark and the destinations, and that are not fully captured by distance. I mean, for instance, you're seeing here clearly that controlling for size and for distance, Denmark exports tremendously more to Sweden, Norway, Iceland, Finland, the Baltic republics here. So perhaps there is something more to distance. Perhaps there are also some, there's not just physical distance, there's also cultural distance perhaps. But let's see about that, okay? I think it is obvious that the gravity equation in the simple form works, and that, if we want to be more sophisticated, we should think of distance as more generally trade costs. What are the trade costs? Well, there are several different types of costs associated with exporting a good abroad. There are policy barriers. Right? Those are the barriers that are affected by policymakers. Tariffs and non-tariff measures, those involve all sorts of regulations, right? From the rules that control the type of electric plug that you allow in a particular market, to all the paperwork that you must file if you want to export some goods in, say, the European Union, as we've discovered with Brexit. And so those are all policy barriers that reduce bilateral trade flows. Then there are transportation costs. These are perhaps greatly captured by the distance variable. Those are the shipping costs, the costs associated with insurance. And I mean, I talked about the importance of containerization, right? In the last few weeks, the importance of that has become quite relevant for the general public, with what happened in the Suez Canal. And so actually, an interesting topic to know, you could imagine that a thesis can study the effects of these different types of trade costs on trade flows, okay? This is always very important to know which particular trade costs are the most important and which are not, and what type of changes generate the largest reduction in trade cost and therefore the largest promotion of international trade, and which do not. Finally, there's also some transaction costs. Those perhaps capture, currency barriers. For instance, the fact that if you export, say, to the US, you're likely gonna get paid in dollars, unless perhaps you're pricing in euros or maybe in DKK, but I doubt that. So if you receive dollars, you cannot use those dollars to pay your Danish workers in Denmark. So there are some costs associated with exchanging the currency, hedging against the exchange rate risks, and so on. Then there's also language barriers, right, that obviously affect the transaction costs. So a question that we might have is, how big are these trade costs? Well, they're quite big. Here I'm showing the results from a paper by James Anderson and Eric van Winkoop, which we're actually gonna, these two authors we're gonna talk about more at towards the end of this presentation. So this is a paper on the Journal of Economic Literature, which, as the title says, is a collection of articles that broadly describe the the current state of a given field of research. And in this paper, they basically study everything you need to know about trade cost, as to almost 20 years ago. And so what we're seeing here is, for different values of this sigma, and we'll get back to that, there's various estimates here that estimate the effect of trade costs measured as a tariff equivalent. Meaning all of those trade costs that we talked about, on average, according to Head and Rees, those are two economists at UBC, University of British Columbia, it costs 48% more to export a good than to sell it domestically on average. So on average, when a Danish company sells a good to Aarhus, pays a certain cost. If the same good is sold abroad, on average, that cost 50% more. Now, there are differences in the estimates. Okay, you see here the estimates range from 35% to 174%. And obviously, all of these things, you should think of them as averages. Right? So perhaps it costs less than 48% for Danish firms to export goods to Sweden, but way more than 48% to export goods to New Zealand. Okay. What about the other trade costs? What about all of the trade costs we sort of talked about? What are their effects? So in this figure, what we have is a meta-analysis of the effects of trade barriers by Kit Head, which I mentioned above, and Thierry Meyer, who basically collect 159 papers. They look at their estimation of gravity variables and report here the median, mean, standard deviation of the coefficients. Of what? Well, typically, you can imagine that a way to estimate the effects of these various variables on trade flows is to run a regression where you have, say, on the left-hand side, so here for you, you have the log, or anyways, a measure of the bilateral trade flows. And on the right-hand side, you have origin GDP, the destination GDP, distance, and a series of other variables. The coefficients of these variables are what are reported in this table. So you see here very nicely that origin GDP and destination GDP have very similar coefficient, pretty close to 1. Our distance has a coefficient of minus 0.8, so that's quite big. So that means that you double the distance, you reduce the exports by about 90%, and up to the log approximation. Then we have a variable called contiguity, which equals 1 if two countries share a border. There would be, for instance, Denmark and Germany, but not Denmark and, say, the Netherlands. And you see, if two countries share a common border, their trade flows increases. If two countries share a common language, also their trade flows increase by 50%. This is pretty big. Then there is a colonial link. So when two countries had a colonial relationship in the past, they tend to trade a lot with one another, everything else constant. Then here we have the effects of various regional trade agreements and free trade agreements. You see that these trade agreements increase trade flows. An example of this is the EU, which does increase trade flows. Same thing for NAFTA. And finally, there is here a common currency. So this is a dummy variable that equals 1 when two countries share the same currency, say the Eurozone. And you see here that there is an incredibly large effect of that. So this is one of those things that is a bit puzzling because it's not like a common currency reduces tremendously your currency costs, okay? But yet, when we look at the data, we say that when two countries share the same currency, they trade a lot. And finally, this home variable, this is just saying that there is a lot of trade within one country. We're going to start with the analysis of the border effects, which is a famous topic in the field of the gravity equation. And we're going to see that there is a sort of a fallacy in the interpretation of the gravity equation if one uses sort of a naive gravity equation. To circumvent that problem, we need a model. So what we're going to see a simple model that generates a structural gravity equation, which allows us to take into account for everything. And finally, we're going to apply the gravity equation framework to the topic of Brexit by looking at an article that measures the cost of non-Europe. The The analysis of border effects originates from a very famous paper by an economist called McCallum, who was one of the first to look at some very interesting data for the US and Canada and found something quite shocking. So what did McCallum do? Well, he had the following estimating equation, where Xij is the exports from a province or a state I to another province or a state J. We know what are the states in the United States, California, Oregon, and so on. A province in Canada is the equivalent to a state in the US. So we have Quebec, Ontario, and so on. Now, these bilateral exports are regressed against the GDP of the province or state, which is the origin I, and the province or state of the destination J. So these log y and log yi and log yj are basically the gravity terms, right? That reflect size. Then there is an indicator delta ij, which equals 1 if what we're looking at, if I and j are two Canadian provinces, and 0 if I and j are a Canadian province and a US state. So before interpreting this gamma, let me just conclude here. What we have as dij, that is the distance between the two provinces or states I and j. So basically here what we have bilateral trade flows, size, the y's, distance d, and then we have this indicator delta. What do we expect the gamma to be equal to? Well, let's think about this. So if gamma is positive, it means that when delta is 1, so when we're looking at two Canadian provinces, the trade flows will be larger, controlling for size, controlling for distance. If instead gamma is negative, well, that means that when delta is 1, so we're looking at the trade flows between two Canadian provinces, there is less trade flows between them, controlling for size and for distance, relative to the trade flows between a Canadian province and a US state, given the same GDP, given the same distance. So if we think that there are border effects, if we think that when you export from Canada to another place in Canada, you're going to encounter fewer costs relative to the case in which you export from Canada to the US, controlling for GDP and distance. Well, if that is the case, we expect this delta to be positive. Okay? So what is the exercise here? Once again, well, the idea here is we basically want to estimate that gamma by comparing the trade flows that there are between, say, British Columbia and Alberta versus the trade flows between British Columbia and Washington, controlling for the distance and controlling for the size of Alberta, the size of Washington, and the size of British Columbia. So I remember when Finstra talked about this paper, he was actually present when McCallum, I believe, went to Davis, or perhaps it was in a different seminar room or a different conference, and presented this paper for the first times. And he basically asked the audience, what do you think is the effect of the border? How much more do you think there is trade flows between British Columbia and Alberta relative to British Columbia and Washington, controlling for GDP, controlling for distance? Think of a number. Thought about it? Yes. You're probably wrong. Why you're wrong? Well, because the border effect is between 16 and 22. So the estimates of McCallum states that when British Columbia trades 16 to 22 times more with Alberta than it does with the state of Washington. This is a huge effect, right? So this was very shocking at the time because it sort of suggests that there are very large trade costs associated with crossing the US-Canadian border, there is a reduction in this border effect between 88 and 93. So that's perhaps the role of NAFTA, but it's not like we would expect to be incredible barriers that hinder the trade between Canada and the US, okay? So that's why this is so surprising. Especially when you do the same thing for the US, you find that the border effect is much, much smaller. So this is very surprising, right? Because it says that, okay, if you're a Canadian firm, you find it so very expensive to export to the US relative to Canada, so much so that basically you trade more with Canada, like 16 times more. But if you're a US firm, you only trade 1.5 more with another US state than you do with the Canadian province. That sounds a little bit strange, okay? And so how can we make sense of this? Well, before we try to make sense of this, let's, with a serious model, let's just humor me with a simple example here. So imagine a frictionless world. Okay, so suppose that there's only US Canada, there's no trade cost. This could be like a Krugman world if you like. And suppose that the US accounts for 90% of the size of this two-country world, and Canada accounts for the remainder 10%. And so that means that the US has 90% of the income and is also 90% of the production. Same thing for Canada. When we think about the total consumption of these two countries, if the US has 90% of the income, that means that the US consumes 90% of what it's produced in the US and 90% of what's produced in Canada, because there's no trade cost. Consumers are identical. Similarly, Canada only accounts for 10% of the world economy, and as a result, accounts for 10% of the Canadian production and of the US production. Okay, so that's what Canada consumes. And so if we create a matrix with sort of bilateral trade flows controlling for size, so what we have here is the exports from the US to the US or Canada divided by the income of the US is 90% in the US and 10% in Canada. Whereas the exports from Canada as a share of total Canadian production are 90% in the US and 10% in Canada. That's what we said before. Okay? Now suppose that there's a border created between the two countries that reduces trade by half. Okay? So what does that mean? Well, that means that for the US, you used to export 10% of your total production to Canada, and now you only export 5. Canada instead used to export 90% of its domestic production to the US, and now it exports 45%. So this means that the domestic trade increases from 90% to 95% for the US case. Right? So that's small, right? That's a small effect. And from 10% to 55% for the case of Canada. So what does that mean? Well, that means that there is the effect of the border. The effect of the border is that it reduces trade by half. But when we look at the domestic trade flows, what we see is that, well, the domestic trade flows of the US increase very, very limitedly, whereas there's a ridiculous increase in the case of Canada. So this is sort of what McCallum found, right? So McCallum found that internal trade in Canada was very, very affected by the border, whereas the internal trade in the US was only minorly affected. But so what we're interested here is, you know, of course, we're interested in knowing what is the effect of the border on these two countries, right? But typically, we would like to know what is the actual, you know, the direct effect, the direct extent by which the border affects trade flows, right? Because otherwise we may think that the border has an asymmetric effect across countries, when in fact it doesn't. So what we want to devise is a strategy that allows us to estimate the actual border effect, which in this example is that the border effect reduces trade by half. And then we would like to generate a model such that this change in the border effect, this creation of the border, generates asymmetric effects on the exports of countries, for instance, depending on their size. And that's what we're going to do with this so-called structural gravity model. The model we're going to see now is, if you like, very similar to the Krugman model. This is often referred to as the Armington model, because it's kind of like a Krugman model where each country produces a number of varieties, and countries differ in terms of the number of varieties they produce and the type of varieties they produce. But we're not going to have monopolistic competition, and in fact, we're going to have perfect competition. So we're going to have a standard CES utility function, which now we're very familiar with. And so here the utility in a country J equals the summation across all origins I, across all of the varieties that they produce, indexed by K, of your consumption of a good K, variety K, from I to J, to the power of sigma minus 1 over sigma, like always. So CKIJ is the aggregate. Okay, we're just making it so we have one consumer in each country. Consumption of variety K from I to J. Now we're gonna make the simplifying assumption here. Don't worry, this does not cause us too many troubles. That all varieties that come from a particular origin are sold at the same price. So this means that you're gonna consume the same amount for all the varieties that you import from a country. You know, if all the varieties of beer that you buy from Germany have the same price, and you have CES utility where you like all the varieties in an equal way, there's no quality weights in this utility function, right? Then you're gonna split your income equally across these different varieties of beer. Okay, so your utility simply becomes, you know, your CIJ, your quantity consumed for any variety from I to J, to the power of sigma minus 1 over sigma, times the number of varieties that you're importing from country I. And you sum that across all the origins. This is another difference with the Krugman model, in that here we're looking at multi-countries, right? Indexed by I from 1 to C. As in the Melitz model, we're going to have iceberg trade cost, tau ij. And so that there's an iceberg trade cost of exporting from I to J greater than 1. If you do not export, if you sell from I to I, the trade cost, the tau, equals 1. So there's no trade cost. And as we said, basically what it means that if you want to consume Cij units of a good, you have to produce Yij units, which is tau times C. Because when you ship Y units, tau units will melt. Tau minus 1 units will melt away. Since we have perfect competition, there's no markups, right? What this would actually be the case if you had constant markup as well, like in the Melitz model. The price from I to J equals the domestic price of a good, PI, times the iceberg trade cost. When you solve the consumer problem, you find the typical demand that comes from CES, where these PJ are the price indices, so the exact price indices, the summation across all of the varieties of the price to the power of 1 minus sigma. Right, so this is across all countries. And so you see here, the price index is, you basically are summing over all origins, summing over all the prices of all the varieties they sell. And so you can imagine the changes in the number of varieties and in the trade cost, which affect the prices, will affect the price index. And with that, your welfare. Now, what are the exports? Well, total exports are, Xij is the number of varieties I times the price times the quantity, right? So if you get this Ci, you multiply it by Pij and Nij, you get this formula here, okay? Now, what can we make of this? Well, the issue, if we want to know what are the exports from I to J, we need to find, a few general equilibrium objects, right? In particular, the price indices. And so don't worry too much on how to actually do that, because Anderson and Van Winkop did it for you. They actually found that the price index are implicitly solved by this system of equation. You basically have the price index of J as a summation of a function of the other country's price indices. So let's think this through. So here we have the price index in a country J to the power of 1 minus sigma. Right? So this is sort of the inverse of your price index, of how expensive it is. It's a measure of welfare, if you like. And this is a function of a summation across all countries of sort of the iceberg trade cost tau ij over the price index. And this is all to the power of 1 minus sigma. And then we have SI, which is the GDP share of country I over the world GDP. So what does this mean? Well, first of all, this is implicit solution because obviously PJ is on the left-hand side, but also on the right-hand side, right? Because we have it here, okay? And of course, this is a system of equations. So you have this, basically you can stack this up for all countries from 1 to capital C. So what this is saying? What this is saying, let's say in a way, okay, let's try to be, like engineers. Let's just cut to the bone. Let's forget about the details and let's think this in a very coarse way. So the price index in country J is basically a function of the prices of all the varieties that you buy. So where are these varieties coming from? Well, they're coming from different countries. Okay? And since they come from different countries, well, how do they affect your price index? Well, they affect your price index by the size of these countries, as I. Obviously, if we go back to the previous example, and Canada imports 90% of the Canadian consumption comes from the US, right? So if something happens to the prices in the US, that will have a much larger effect on the Canadian prices than, say, if something happens to the prices of goods from, I don't know, from San Marino, okay? Then this price index in country J also depends obviously on all the iceberg trade costs. Why is that? Well, because if you import goods from Sweden, obviously, given that the price of the goods of an exported good from Sweden to Denmark depends on the iceberg trade cost, the higher the iceberg trade cost, the higher the price that you need to pay. So you see the tau is sort of proportional to that Pj. And then this P tilde I, notice that is inversely related to Pj, okay? And why is that? Well, this is the so-called, this is why we think of these price indices as so-called indexes of multilateral resistance. Because in that, there's basically all the general equilibrium effects that determine how much you are importing from a given country. If a given country has a very high level of the price index, you're not going to import it from that country a lot, right? Because its prices are simply way too expensive, so you don't buy too much from them. But if a country has a very low price index, That means that country is relatively competitive. So the prices of the goods there are relatively cheap. So you're gonna buy more from there. But then here you see the system, right? Why are the prices in a country particularly cheap? Because perhaps that country not only has better technology and low domestic prices, but perhaps that country is also very well connected to all the other countries in the world. In other words, it has very low iceberg trade costs. And so this is what this system of equation is capturing. It's capturing the direct effects of iceberg trade cost and country size on the price indices, but it's within it, it also has these general equilibrium objects whereby country size and iceberg trade cost determine your price index, which in terms determines how much your goods are imported from all over the world. Okay, obviously it's very difficult, oftentimes to make sense very rapidly and very quickly of the general equilibrium effects, but I hope you at least realize here that that's what's happening, that there are these general equilibrium effects. Okay, so what is the gravity equation? Well, the gravity equation is simply your bilateral trade flows are proportional to the product of the country's GDP, IJ, normalized by the world GDP. Then we have tau ij to the power of minus sigma. And then on the bottom there, we also have these two price indices. Price indices P tilde I for country I and P tilde J for country J. And you basically see that trade flows are proportional to country size and inversely proportional to distance. And what is distance? Well, distance is the iceberg trade cost tau ij and the multilateral resistance terms, which are these price indices, okay, which capture all the general equilibrium effects and captures, the competitiveness and the proximity, in a way, of countries I and J. So why does this matter? Why are we doing this? Well, we're doing that for the following reason. I remember we came from the study of the border effects. We saw that if we have, a simple gravity equation, if we put in a border effect, we find huge border effects for the small country and large border effects for the, and small border effects for the large country. So how does that plays out in this particular model? Well, let's see. Suppose there is a change in the trade cost tau. In the current trade values, we have this formula here. Here bar does not denote an average value, okay? It's just to denote the current value without having to add additional subscripts or superscripts. So we have that the current value of trade flows depends on the country's GDP, the size, and then that depends on the iceberg trade cost today and the various price indices today. Now, don't worry too much about the GDPs because typically we bring this to the left-hand side and look at the trade flows relative to GDP. Okay? Focus just on the right-hand side here and in particular the second term. So if there is a change in the trade cost, there's going to be a direct effect of that. Tau changes, multiply, the elasticity of iceberg trade cost with respect of x to x is 1 minus sigma. So if tau increases by a certain percentage, well, that percentage times 1 minus sigma, which is negative, will reduce the iceberg trade cost. That is the naive approach. That is the McCallum approach. That is the direct effect. But what's going on as well is that there is a general equilibrium effect. Not only the iceberg trade cost change from tau bar to tau tilde, but also the price indices change, okay? How do they change? Well, we need a computer to do that. We need to go back to this slide and solve the new vector of price indexes given the new vector of iceberg trade cost, tau ij, okay? And so when we do that, what we find is that the ratio of exports basically depends on the ratio of the iceberg trade cost. And this is the direct effect. Okay? If you also like, we can call this a partial equilibrium effect. You know, the effect of increasing, of say, putting a border between the US and Canada, holding everything else constant. So this is perhaps very important to understand the partial equilibrium effect if you want to compare different trade costs. But if you want to study how a change in trade cost affects total trade flows, you also need the general equilibrium effects, which are captured by the price indices again. Okay? And now, you know, this, for instance, accounts for the fact small economies are going to experience larger border effects for the reasons we showed above, right, with the simple example before. But so it's generally difficult to clearly outline what's going to happen to the price indices. Because the way to think about it is, okay, so if say there is an increase in trade costs between Germany and Denmark, what's going to happen to the price indices of Denmark? Well, again, that is the general equilibrium effect. The price indices of all countries in the world will be affected. If there is an increase in trade cost between Denmark and Germany, the price indices of all countries in the world will be affected. How is that possible? Well, it's because of the general equilibrium effects. If the German economy finds it more difficult to export to Denmark, that means that the price index in Denmark will increase. If the price index in Denmark will increase, that means that all countries in the world will probably export perhaps a little less from Denmark, right? And so on. Another way to think about it is to think that these price indices are basically measuring the expenditure function, right? The expenditure value for the countries. And so if there is, say, an increase in the trade cost between Denmark and Germany, that means that the level of expenditures for Denmark will probably decline, right? And so what will that entail? Well, that will entail that perhaps the level of expenditures for all countries with that Denmark straight to will also change as well. What can also happen is that now if it is more expensive to export for Denmark to import from Germany, well, perhaps Denmark will start importing more from other countries, say Sweden. So there's going to be a change in the price index for Sweden as well because of this change in the composition of the consumption for Denmark. And as a result, the change in trade cost between Denmark and Germany also affects the trade flows between Sweden and Denmark. How does this relate with the border effect we studied above? Well, what we need to find is find a way to estimate the gravity equation that we showed above. This gravity equation. How we do that? Well, first we take logs, and then what we need is some functional form for the iceberg trade cost. You understand that the iceberg trade costs do not exist in nature. That is just an economic abstract construct which captures all the trade costs associated with exporting from I to J. And so for our analysis of the border effects, what we're thinking is that the iceberg trade cost is a function of the border effect delta, then it's proportional to the log of the distance, dij, with an elasticity rho, and then there is some additional error that we're not going to worry about now. So if we take the log of the gravity equation, what do we get is the following. We get that the log of trade flows from I to J divided by the country's GDP, what is it equal to? Well, it's equal to the indicator that we saw before of a border effect delta. We have here the distance. We don't need to control for GDP because we had it on the left-hand side. And then we have these indexes of multilateral resistance. Now let's open a parenthesis here. At the very beginning, I showed you that the effects of trade costs on trade were somehow dependent on some assumption over the parameter sigma. Okay. Why is that? Well, you can see it here. You can see here that the effects of say, changes in distance on the value of trade flows depend on the parameter rho and the parameter 1 minus sigma. And you cannot separately identify these two parameters, unfortunately, right? That is just one single beta, right? But you need the value of sigma to, say, also evaluate the effects of the border effect, for instance, right? Or for any other variables. And so if you don't find a way to estimate the sigma, you just put some values, okay? Some reasonable values that are coming from other papers. And so that's what they're doing. Close parenthesis. So this is the gravity equation that Anderson and Van Wink could estimate. How do they do it? Well, there's different ways. You can use data on price indices. You can use fixed effects. I don't worry too much about that at the moment. But basically, when they estimate this equation, they find that the partial equilibrium effect of crossing the border is relatively small, 1.65 or 1.55, depending on the estimation procedure. So that in red is the partial equilibrium effect, the effect of simply changing the tau because you have a border. But then if you apply sort of the general equilibrium principle, and you look at the counterfactual in which you say you either go from no border to border or vice versa, you re-estimate you solve for the new price indices, you compute the change in trade flows, and what Anderson and Van Wink could find is that indeed the border effect for Canada is very large, and for the US is relatively small. So we have figured out what was going on there. What McCallum did was simply looking at the partial equilibrium effects of borders. What Anderson and Van Wink show is instead that there is a partial equilibrium effect and a general equilibrium effect. And in this case, but also in general, the general equilibrium effects tend to be much larger for the smaller economies than they are for the bigger economies. Now we are in the Brexit situation, right? Before Christmas, they found a deal, although they didn't cover all of the things it was supposed to cover. Still don't know what's going to happen for the financial sector. But basically what happened is that the UK exited the European Union. What is the European Union? Well, it's a regional trade agreement that is actually a customs union, meaning all the countries within it have no tariffs between them. And on top of that, they share the same trade policy. In other words, if you're if you are a firm from the US exporting to Denmark or exporting to Germany, the tariffs you pay are exactly the same. Now, the European Union is also more than that, in that it also has a single market. So basically, that is the attempt to reduce at the lowest possible value all barriers associated with exporting within the European Union. So at least in terms of exports of goods and also movement of workers, the European Union is the attempt of making Germany and Denmark the same as Fyn and Mid-Jutland, okay? The UK exited the European Union. Obviously, if we look at it from a trade point of view, we know that that's going to reduce trade flows, right? We saw before that being in the European Union increases trade flows. This is not so good for welfare, right? Because that means that there's going to be less variety in the UK, there's going to be higher prices, there's going to be lower consumption. Whatever trade model you pick, you find that welfare is going to decline. And so the big question is, well, is this Brexit worth it actually? Obviously, if you look at the news, we've seen in the last 4 years several different doom predictions. Obviously, if you look at trade economists, none of them ever said that there's going to be a recession in Britain because of this. We know that changes in trade costs affect trade flows, but slowly, right? The trade is something that happens slowly. It take years to this for this to produce effects, right? And so basically, what the conclusion for trade flows is that there's going to be some reduction in trade flows over the course of the years, and that perhaps will generate some welfare losses. Now the question is, how big are these welfare losses? How can we think of them? Well, that's where this article, Revisiting the Cost of Non-Europe, comes in. So this is a paper by Thierry Meyer, which we also saw above for a paper with head. Vincent Vicar, who also presented in Aarhus, not this paper, but another paper, I think 3 years ago, 4 years ago. And Soledad Zignano, who I don't personally know. And so what are they doing here? Well, they're basically using state-of-the-art gravity equation to study the effects of Brexit. Right? They don't look at the effects of Brexit yet, because by 2018 it hadn't really happened yet. Even now, the data are not in yet. What we can do is to study the effects of entering the European Union and see, imagine that there is some symmetry associated with the benefits from entering and the costs associated with exiting. And so to basically estimate this, all we do is to use a gravity equation. Now, how can we think of this? More generally, right? Not only in terms of gravity equation, right? So if you want to study the effects of being in the European Union, what can you do? Well, one option is to look at a cross-sectional data. So you look at all the trade flows that you observe in the world, say right now, and then you run your gravity equation where you compare the trade flows between two countries that are in the European Union versus two countries that are not in the European Union. And you control for distance, for the sizes of the countries, you control for everything you want. What is the issue? Well, the main issue is the selection. The main issue is that countries that are in the European Union are not random, right? They're all close to one another. Most of them have high per capita income, right? So it's very difficult to properly control for this selection effect. I mean, if you observe that there is more trade within the European Union, is it because of the European Union, or is it because these countries are close to one another and they've always been close to one another and they've always had a political relationship for the last 2000 years? So a better way to do that is to look at a time variation, right? So say you look at a panel data, where then you can basically compare the effects of entering the WTO in the European Union. So you see, okay, in this year, this country entered the European Union. If we compare the trade flows of these countries after entry with the values before entry, we control for, say, the country characteristics with a fixed effect, well, then we have perhaps a better measure of the effects of entering the European Union. Obviously, perhaps there are some issues in that as well. Typically, these are issues that involve the question of whether the effects of the European Union occurs after entry or whether it's anticipated before. But so that's basically the approach that these guys do in their paper. They apply a gravity equation, they look at a time series, and they study the effects of switching the membership of the European Union on between a certain country pair. Now, obviously, you don't want to have omitted variable variance, do you? So you want to control for everything that you can. You want to control for everything that is happening at the country levels. If you look at the trade flows between European countries this year, you're probably going to find that European Union has a negative effect because the European countries have been in a constant lockdown and countries in other continents haven't. So you want to control for something that happens in the countries, GDP, etc., right? You also want to control for any possible trade costs that do not change over time. What is the best way to do that? Well, the best way to control for all these things without having to worry too much, the state-of-the-art way of doing this, if you like, is to use dummy variables or fixed effects. I know that now you probably have just learned about fixed effects, and you have sort of a panel data background where you think there is one fixed effect, and here there's going to be more than one. So don't worry about that. Just think of this as dummy variables. So what they do is the following. Look at the trade flows, X, from country N to country I in year T. That's regressed on a dummy that equals 1 if the observation is for the country I in period T. This captures everything that happened in the destination in year T. Whether they had the recession, whether they had a lockdown, whether we had anything, okay? And then we have the same thing for the origin. So we have the dummy variable that's 1 if we have the origin year and T. So, as I said, the destination fixed effect or destination dummy variable captures everything that's happening in the destination in the year. The origin dummy variable captures everything that's happening at the origin in the even year. This is perhaps GDP, this is perhaps protests, this is perhaps anything. Then we have a pair fixed effect. So a pair dummy variable, that's 1, for all the pairs that you have. So when you have, Denmark, Germany, that's 1 pair. When you have Denmark, Sweden, that's another pair. And this basically captures all the costs associated with trading that do not change over time. Distance is always the same. Language typically is always the same. Whether the two countries share a border, that's always the same. So basically here, we're really controlling for everything we can think of. And what we're left is with the bilateral changes over time. And so, for instance, what we have here is some variable, perhaps b, which coefficient b that multiplies whether the pair ni is in the European Union in year t or not. So basically here we're comparing the trade flows between a country pair that switches its European Union status versus a country pair that doesn't, controlling for everything that's invariant between the country pairs and everything that is happening in each country in each year. So this is like a very robust way of studying these sort of things. And so what are the effects of the European Union over time? Well, they're pretty big. Okay, you see here, this is sort of the coefficient. You see it's between 50%. So you see, imagine 57 is when the Treaty of Rome was signed. And 68 is when the custom union actually began. And you see that basically the effects of the European Union has been steadily increasing over time. And when we look at the distribution of the trade effects across countries, what we're seeing is that pretty much all countries benefited from larger trade flows, especially the countries in the Eastern European area, okay? But also the UK benefit from trade. And so, was it worth it? Well, from an economic point of view, the answer is pretty much no. When you look at the literature, the only motivation that I found in recent papers for Brexit that comes from an economic point of view is that the fact that the UK allowed migration from Eastern Europe in 2004 instead of putting the delays that other countries put, caused a reduction in the welfare of the low-skilled workers in the UK, at least for the initial years. So that is perhaps the only economic justification for this. We know that trade is beneficial for countries. We know that trade, however, can cause inequality. So it could very well be that along with the migration, also the trade with the Eastern European countries, which tend to be more different in the UK than Germany, Denmark, and Sweden, perhaps you could say that has caused some, perhaps disadvantages for the people that voted for Brexit. But empirically, that does not really seem to be the case. Okay, so are Brexiters idiots? I don't think so, right? That's just that's too simplistic of an answer, right? It doesn't answer anything really. It's just saying that the people that you disagree with are not very smart, which is not the good way to approach the problem, right? So how can we make sense of this Brexit? Well, perhaps it does not really have to do much with economics. Perhaps it has to do more with other things, just political independence, whatever that might be. Perhaps it's the fault of trade economists or pundits in not explaining well enough why trade is a good thing. So hopefully I'm doing that with this course, so that you guys, whatever might happen in Denmark, will never vote for a Denmark exit. Okay, so that's it for today. Thank you for watching. I'll see you next time. Ciao.